All right, z-scores. First of all, we're still talking about normal curves, okay? So for a z-score to work, you have to be dealing with a normal curve. There we go. Now it's nice and clear. So let's just take a thing that has like a mean of 20 and a standard deviation of 5. Well, that's pretty easy with empirical rule. We draw out our stuff and we end up with 20, 25, 30, then like 15, 10, 5. Okay? But what happens if I ask you about a data point like 13? Like, hey, how much is above or below 13? That's a problem. That's not one of our pieces. So that's where z-scores come in. Z-scores pick up the gap in between empirical rule. Empirical rule only works at 68, 95, and 99.7%. Z-scores work everywhere. And empirical rule is based off of z-scores. So this is the fix-it-all. It always works. So here's the way that you're going to calculate it. Data point minus mean divided by standard deviation. What a z-score tells us, this is important, I'm going to ask you this question probably about 10,000 times. A z-score tells us the number of standard deviations from the mean. It does not tell us anything else, okay? Number of standard deviations from the mean is what a z-score tells you. Don't think it's going to tell you anything else. So we calculate it by data minus mean divided by standard deviation. It tells me the number of standard deviations. So let's just take this 13, for example. So my z-score equals 13 minus the mean, which is 20, divided by the standard deviation of 5. That gives me negative 7 divided by 5, which gives me negative 1.4. So it's negative. That means it's going to be left of the mean. And then 1.4. It's 1.4 standard deviations from the mean. So it is 1.4 standard deviations from the mean to the left. Now, you have a chart. It is on the back of your worksheet. So on the back of the packet. All right, and it's going to look something like that. Okay? All right, I don't care which side you write this on, but I need you to write this somewhere on this. Less than. And I also need you to write percent or probability. Percent or probability. So we're writing less than and percent or probability. This chart tells you the percent that is less than a z-score value. In other words, if we're dealing with this lovely number right here that we've been dealing with for a little while. So we have our normal curve because it has to be a normal curve. We've got our mean. Negative 1 point store standard deviations is like right there, okay? So what the z-score is going to tell us, it's going to tell us the percent of data in that range right there. Okay? How much is to the left of that? That means if I need to find this, I've actually got to do something else. I've got to do 1 minus or 100 minus the percent to actually get an answer. Okay? So that's how it works. Let's just jump into a problem and see where we can go. Also, the reason I told you to write percent or probability at the top of this, if you see the words percent or probability, it means you're using the chart. If you do not see percent or probability, you're not using the chart. All right, so I've created a problem. I know you don't have it. I apologize. Write down the important pieces of this. So important pieces, 2,500 students. Took the math portion of the SAT last April. That's all extra information. On the math portion, the average score, this is important, average score was a 650, And I'll keep sliding it back and forth. Standard deviation of 35. So that's telling me a couple things. First of all, my mean was a 650. My standard deviation was a 35. Okay? So that's what came out of that paragraph. We have a mean of 650. We have a standard deviation of 35. Now, when reading through the problems, you have to underline stuff. First thing to underline, what percent, that is important, scored above a 625. So those are the pieces of information we need to know. Percent tells me I'm using the chart, okay? Above, that means I'm gonna have to do extra work. 625 is my data point. So Z equals data point minus mean divided by standard deviation. So once you type this in, so we do 625 minus 650, enter, divided by 35, and I get negative 0.71. You need to go to 2 decimal places for this. Negative 0.71. Now, how to use the chart. Look at your chart. You see there's a negative side and there's a positive side. We're looking at the negative side. Our number is negative 0.71, which means I need to scroll this side down to negative 0.7, okay? The 1 is going to tell me how far to move across. So I go down to negative 0.7. The first column is 0. The second column is 0.01. So negative 0.71 is that number right there. That is a probability, okay? That is the probability associated with our number. So I come back over here, and my number was 0.2389. So that's a number. I'll explain what it means in a second. Basically what it means is the probability of students that scored less than a 625, okay? Because remember the chart only tells me less than. So this is my less than number. I don't need that number. What I need is the more than number. So you can do 2 things. You can do 1 minus the probability, or you can do 100 minus the percent. And since we are changing this thing over to a percent, we're going to go ahead and change it over to a percent. So this is 23.89%. So 23.89% of my data is less than a 625. To do more than 625, I have to do 100 minus 23.89. That gives me a score of 76.11%, and that is my answer. So it told me I needed a percent. My final answer is a percent. It told me I needed above, so that's why I had to subtract 100, and then I have my data point. So 76.11% of students scored above a 625. Let's look at the next problem. Read through it real quick. I need you to underline what you think is important. So probability less than 710. Okay, so probability means I'm using the chart. Also means I don't need to convert to a percent. Less than, I don't have to do extra work. And then 710 is my data point. So first step, find your z-score. 710 minus 650 divided by 35. Type the top piece in, hit enter. Type the bottom piece in and hit enter. You get 1.71. So that means my data point is 1.71 standard deviations above the mean. Now I'm going to use these 2 values to go down the chart. I'm going to use this value to go across. So I need to go to the positive side of my table. I look up 1.7. All right, there's 1.7. And now I need to go across to 0.01. And it's that number right there. So we can write it down, 0.9564. 0.9564. It's probability. I don't need to do anything else. That's a probability. Less than means I don't need to do extra work. Therefore, that is my solution. Okay? All right, one more problem before you can start doing practice. Percent students scored between a 550 and a 690. All right, so we have 2 data points in this problem. That means we're going to have to use the chart 2 times. We're going to set up 2 different problems. We're going to set up our 550 score. So 550 minus 650 divided by 35. And then our other one, which is 690 minus 650 divided by 35. All right, if you do the math from the first one, you come out to negative 2.86. Okay? And then you do the math on this one, you come out to 1.14. Now, here's what I need you to do. Go into the table. Hit the pause button on this video. Go into the table. Find the 2 z-scores associated with those numbers. So, negative 2.86. Go to the negative side. Remember, the first 2 things are what we go down. Negative 2.8 is there. And then I need 6. So I go across until I'm at the 6. 0.0021. So 0.0021. Now I need to do the same thing with 1.14. Go to the positive side. I go down 1.1 and then I go across to 4. 0.8729. Now, if I want to know something between mathematically, that means I need to subtract. So I subtract those 2 values. 0.8729 minus 0.0021. And I end up with a value of 0.8708. So that's the probability of a score falling between those 2 values. Now I need the percentage of scores that fall between them. So that means move the decimal 2 places. That means 87.08%. 87.08% of students scored between a 550 and a 690. I want you to do the practice problems on the page. You're not doing the entire worksheet, you're just doing a couple of problems. So do those couple of problems, then come back on here and I'll show you how to do the rest of them.